So yes, I'm Martin Rouy. I'm a PhD student supervised by Dr. Nathan Pebb, and I'm going to talk to you about some recent results from a meta-analysis we did on the calibration of confidence judgments in individuals with schizophrenia. So as an introduction, we can say that some of our mental states are depictions of the outside world, whereas some other only pertain to our subjective world, for instance, memory, mental imagery, imagination, and so on. And in order to draw the line between these outer and inner contents, we have actually the capacity to reflect on them. And for instance, we can monitor the quality of the representation, giving rise to a feeling of confidence about its accuracy and consistency. And this evaluation enables us to distinguish between what is real or the outer world and what is strictly subjective. This capacity is known as metacognition, and psychotic experiences like delusional beliefs and hallucination has been considered to be the result of a metacognitive deficit. That's to say, the inability to distinguish between what is real, the outer world, and the inner world, right? So in this meta-analysis, we thought to quantify this metacognitive deficit in schizophrenia. So in order to do so, we included studies in which, of course, we had individuals with schizophrenia, but also healthy participants, healthy control participants, and experiments in which we had a confidence judgment task. So let's take an example. It means that in each trial, a stimulus is displayed and participants are probed with a first order cognitive task. Here, for instance, it's a memory task, but it could be perceptual or other cognitive task. And then they have to ask, they are asked to report their confidence in their previous response. And actually the ability to calibrate the confidence on their previous performance, their previous answer, is a proxy for metacognition. And usually healthy participants are quite good at it. They're able to do it. They're able to discriminate between their correct answers and errors on the basis of confidence. And in contrast, patients with schizophrenia reveal underconfidence in correct answers and overconfidence in errors. But this metacognitive deficit here is not replicated in some recent studies. Here it's a perceptual study where actually there was no metacognitive deficit. Here on the x-axis, you have the M ratio, which represents the ability of participants to calibrate the confidence on performance. You have the estimation for control participants in blue and the estimation for individuals with schizophrenia in red. And here there are no difference between the groups, meaning no metacognitive deficit. So you might say, hey, maybe it's just a sampling error, just an isolated case, but actually not at all. We have recent studies who find similar results. So now the question is how to reconcile these recent findings with earlier studies. And investigating this issue, we have found that actually there is a common feature between all these recent studies. They have actually controlled for first order performance. So now you should ask why controlling for first order performance matters. Actually, Andrew has already brilliantly introduced this topic during his talk, but let's adapt it with the case of schizophrenia here. Cognitive deficits are well documented in schizophrenia, leading to poor task performance in patients. And being less accurate, actually patients, it should be more difficult for them to calibrate their confidence on their performance. So what we are saying here is that if not controlled, the cognitive deficit risks to contaminate the metacognitive measures, artificially inflating the metacognitive deficit. So the question we are addressing in this meta-analysis is the following. Does controlling for first order performance influence the metacognitive measures? And based on the previous literature, we have hypothesized that the metacognitive deficit would be decreased in studies controlling for first-order performance. And we also explored the influence of cognitive domain on the amplitude of this meta-deficit. So we did a systematic review first, consisting in entering some specific keywords in predetermined databases. From this, we retrieved almost 8,000 entries after duplicate removal. And after the long process of screening, we ended up with a final selection of 42 articles. Then we extracted the data. In each study and for each group, we extracted the first order cognitive performance as well as the second order metacognitive performance. And from these raw scores, we computed an effect size, here an HSG, which is like a QNSG. It's just the difference of means between the two groups divided by the pooled standard deviation. And we also extracted the predictor of interest, so whether the first order performance was matched between groups, so true or false, and also the cognitive domain investigated. So we had memory, perception, social, and agency studies. So now let's look at the results. What we did is a Bayesian meta-analytic model. So just briefly, the advantage of this approach are that it enables us to include the prior knowledge based on the literature. So here we specified a mildly informative prior centered on minus 0.3. And it also enables us to validate the null hypothesis, contrary to the frequentist approach. So now let's look at the forest plot of our meta-analysis. On the left, you have all the authors with the date of publication. On the x-axis, this is the effect size of the meta-deficit. So the more we go to the negative values, the more important the deficit. In the middle, you have all the posterior distribution for each study, which are obtained by multiplying the data by the prior. And on the right side, you have the mode of each posterior distribution along with the 95% credible interval. Now let's look at the very bottom line. This is the estimation of the meta-deficit given by our meta-analysis. You can see that this is quite precise. It is centered on minus 0.57. And actually, if we stop the analysis here, we would say that we have tremendous evidence here for the existence of a metacognitive deficit in schizophrenia. But wait a minute. Now let's look at the influence of performance matching between the groups. So here in the model, we just add the binary variable, the control of first order performance, which is true or false. So now we have two estimations of the meta-deficits. The x-axis is the same as in the forest plot, and we have an estimation for studies which did not control for first order performance, and the estimation in light gray for studies who did. And here what we find as predicted is that the meta-deficit in control studies is smaller and then even twice smaller than in non-control studies. So here we have computed a base factor, which is the ratio of evidence available for our hypothesis compared to the null hypothesis. And this number, 45, indicates a very strong evidence for our hypothesis, namely that controlling for first order performance would decrease the metacognitive deficit. So now let's look at this subset of studies, those studies controlling for first order performance. We are just zooming in this part, right? And now we assess the presence or absence of meta-deficits in this subgroup. So we did the subgroup analysis, and now we have computed the base factor, which is now only 1.3, and which is actually inconclusive, meaning that we can neither accept nor reject the null hypothesis of an absence of metacognitive deficit in schizophrenia. Right, and then we look at the influence of cognitive domains. So here in the model, we have put the categorical predictor domain, which has three modalities, memory, perception, and others. What we have called others is just agency and for social studies. So here we have three estimations of the meta-deficit. One for the meta-memory, one for in white for the meta-perceptual meta-deficit, and one, the meta deficit for other cognitive domains in gray. What is interesting here is the meta-memory deficit. You can see that it is 2 or 3 times higher than in other domains. But this is not sufficient to conclude, actually, that there is a meta-memory deficit here. Why? Because among the 27 studies in memory, actually only one has controlled for first-order performance. So this could also be the result of a confound. Okay, having said that, let's remark that this only study controlling for first-order performance in memory did find a meta-memory deficit which was higher than in other cognitive domains. So, as a conclusion, so just sum up what we have talked about on the influence of controlling for first-order performance. We have shown that the metacognitive deficit is reduced by a factor 2 in control studies, and that in this subset of studies, the metacognitive deficit is inconclusive. Okay, there is an obvious limitation in this result because we had a limited number of control studies. So let me warn you something. So just a spoiler alert, we will make available soon the scripts and our methods. So please, those interested, feel free to upload your data so that you can keep this meta-analysis updated. And then on the influence of cognitive domains, we have shown that memory studies contribute the most to the metacognitive deficit. But there was also a striking limitation because only one memory study controlled for first-order performance. So the question remained whether it was a localized meta-memory deficit or just the result of a side effect, the side effect of a confound. So this meta-analysis is also an appeal to build more robust protocols in order to arbitrate between these two hypotheses. And finally, of course, we have also extracted the clinical scores and the antipsychotic dosage. But surprisingly, we did not find any correlation, any relation with the metacognitive deficit. Okay, so that's all. Thank you all for your attention.
Thank you, Martin. Thanks a lot. Very, very, clear talk, exciting work. While people are formulating their questions, I can kick off. So what I was thinking is that your analysis would depend quite a bit on the priors. So how plausible is your prior distribution that you were using, which is, with a mean of -0.3 and a variance of 1. So if you use this, so how plausible is that?
It's an excellent question, and actually we have done what we call a robustness analysis. So we have tried the same analysis also with different values of prior, and actually it doesn't. There is not so much variance when we change the value of the mean here. What is important is the value of the precision, and because we entered a mildly informative prior, which is quite a lot of variance here, this does not affect so much the final result.
Okay, good. Yeah, I mean, are there any further questions? Actually, we are behind the schedule. We should be closing the room in a minute. So, yeah. So thank you.